Hello, my name is Shivani. I'm a new Wyzant tutor, and I'm here to help with a physics problem involving specific heat. So let's get started and read the question. The mass of the object is zero point 0.5 grams, and it's determined experimentally that it takes 20 joules to raise the temperature by 10 degrees Celsius, and we need to find the specific heat in joules per kg per Kelvin, or joules times kg raised to the -1 power times Kelvin raised to the -1 power. So I've set up the problem here. So the specific heat has to be in units of joules per kilogram per temperature change in Kelvin. So I've listed the known values here. The mass is 0.5 grams. Now, the question asks us to find the specific heat per kilogram times Kelvin. So I have to convert the mass to kilograms. And when converting from grams to kilograms, we divide by 1,000. So I did 0.5 divided by 1,000, and I got 5 times 10 to the power -4 kilograms. The heat added is 20 joules, and the temperature change is 10 Kelvin. Now, even though Celsius and Kelvin require conversion, the change in the temperature is always going to be the same, whether it's in Celsius or Kelvin. And that makes sense because if you're converting between Celsius to Kelvin or Kelvin to Celsius, you're just doing addition and subtraction. So the temperature change is always the same for Celsius and Kelvin. Let me just note that down. All right. So we can go ahead and use this information and then plug in chug to calculate the specific heat of the substance. So we have 20 joules divided by 5 times 10 to the -4 times 10 and let's go ahead and plug this into our calculator. So 20 divided by 5 times 10 to the -4 times 10.0. So I ended up with 4 times 10 to the 3 joules per kg times K. Now we can quickly check our answer by plugging in this specific heat value into the equation delta H is equal to mass times specific heat times delta T. So delta H, so it has to be equal to 20 joules because that's how much heat the sample required. So that would be equal to 5 times 10 to the -4 kg times 4 times 10 to the power 3 joules per kg times Kelvin times 10.0 Kelvin. And notice the units cancel out. Kilogram and kilogram cancel out. Kelvin and Kelvin cancel out. Then you're left with joules as the final unit. And so delta H is 20 joules. All right, so this is our final answer. Four times 10 to the power 3 joules per kilogram times Kelvin. All right, so that pretty much wraps up the answer and the explanations. If you have any questions, feel free to leave a comment in the comment section, and I hope this helps. I hope you have a wonderful day.